All right, today's lesson is 11.1 Permutations and Combinations. I did decide to do a handout for this one because there's just a lot of writing. There's a lot of word problems. So you can absolutely write them all on your own or print out the handout, whatever is going to make it easier for you. But you'll be able to take notes faster, and I can get through the notes faster if I have the words all written. So one key concept here that we're going to be using is the fundamental counting principle. So this says if event M can occur in M ways and event N occurs in N ways, to find, we just multiply M times N ways. So the example is 3 pants and 2 shirts would give 3 options for pants, 2 options for shirts. Multiply them together to get 6 possible outfits. Okay, and for visually, you can make tree diagrams. Maybe you made this tree diagrams in middle school. So if you have, one particular pair of pants, you have some black pants, pants 2, you have some jeans, pants 3, you have sweatpants. Okay, and then you select one, and now you have one of the shirts to choose from. So that means there would be 1, 2, 3, 4, 5, 6 options. So the 3 pairs of pants, each of those pairs, you could choose another shirt or the 2 shirts. So that's 3 times 2. That's your counting principle. You are multiplying the amount of different options together. We are going to use the counting principle throughout our lesson today. So looking at a little bit more complicated of an example than just 3 times 2 would be looking at license plates. So the license plates for Maryland, their requirements are listed below. So if we look at 2004, what was required was there needed to be 3 letters and 3 digits, so 3 numbers. And then in 1912, only 4 digits were used. Okay, so we are going to find the amount of options there would be for license plates in these 2 different years. Okay, so if there are 3 letters, okay, I got to think about how many letters are there. There are 26 letters, so there are 26 options, and a lot of students will want to do 26 times 3. Okay, but I'm not doing 26 times 3 because that would be adding 26 3 times. I'm taking 26 times 26 times 26 because there are 26 options for one of those letters, and then another 26 and another 26. If I look at next the 3 digits, so thinking about I can have 0 as a digit and then only single digit numbers. So 0 through 9 would be 10 options. So that means there's 10 options for one of the numbers, but then I need to choose another number and another number. So here are my 3 letters followed by the 3 numbers, and multiply all that together. So there are 17,576,000 different options for those license plates. Okay, if we look at 1912, obviously older or more in the past than 2004 would be, only 4 digits were used, so 10 options for each digit. There are 4 of them. So 10 times 10 times 10, or take 10 to the 4th power. So there would be 10,000 different license plates. Okay, so the more options we add in, so the more letters we have to select or the more digits we have to select, the more we're going to be multiplying, and the larger amount of options there would be for license plates. You can use this concept for passwords, right? We need a lot of passwords these days with different online accounts. Some of them require a certain amount of characters. Some of them say you have to use a special character. You have to use an uppercase letter, a lowercase letter. So all those different things you have to select are going to make it larger and larger amounts of possibilities. Okay. Okay. So we're also going to continue to use that counting principle idea with this next example. So let's say we've got 3 students extremely excited for Algebra 2 class. They're waiting outside my room at 6:30 a.m., you know, back in the day when we were all here in person. All right, so how many different orders can 3 students line up at the front of the door? So I've got 3 students that are there. Okay, so I think about there's a spot for 1 person. So, but there are 3 people that could potentially get that first spot. Okay, and then someone stands there. And then now there are 2 people left potentially for that second spot. And then one of my students stands there. And then the last student will get the last spot. So I'm multiplying those different options. So 3 times 2 times 1, there would be 6 different possibilities or ways those students could line up. Okay, so I'm using that counting principle, multiplying the amount of options together. This is also considered a factorial. So this is the same thing as 3 factorial. Yes, that's an exclamation point, but in math, it means something. It means that whatever number I have right here, I start with that number. So n factorial, I'll start with n, and then I multiply by a number that's 1 less, so 2. And then a number that's 1 less than the previous number, so that would be 1, and then I stop when I get to 1. So if I had to calculate 8 factorial, I would take 8 times 7 times 6, 5, 4, 3, 2, and 1, which you'll want to calculate for today's lesson. So that would give me 40,320. So that would be the answer if I said there are 8 students that showed up this morning and all 8 of them lined up. How many options would there be for those lineups? There would be 40,000 options, 40,320. Okay, these last 2 examples are also considered a permutation. Okay, so today we're going to talk about, we already talked about the counting principle, and then we'll talk about permutations, and the next one will be combinations. So permutations are an arrangement of items in a particular order. So they have a particular place they need to go. The first 2 examples I'm talking about are lining up in a certain order. Okay, so that would make it a permutation. There is a little formula for permutations. All right, and there's also a way you can do this on your calculator, so I'll explain that as well. So if you have a scientific or graphing calculator, you'll be able to perform this on your calculator. If you don't, I'm still going to show you how to do it by hand, so everyone will be able to do these problems either way. So if I'm evaluating 10P4, I'm going to fill it into this formula. So if we think back to the example I'm talking about, if I said I have 10 students in one class, okay, and 4 of them are going to line up at the door. So this would be, I'm going to calculate how many options there would be if only 4 of my 10 students were able to line up at the door. Okay, so I'm going to fill it in this formula so you see how to use this. So n factorial, here's my n. So 10 factorial over, I do n minus, here's my r, factorial. So 10 factorial over subtract 10 minus 4 first, so that's 6 factorial. Okay, so I'm going to write all this out now. So 10 factorial is 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. There will be a shortcut to this. I will show you in a moment. And then 6, 5, 4, 3, 2, 1. And now what you should see before you multiply all that out is that, well, 6 divides 6, that goes in 1 time, and 5 and 5, and 4 and 4, 3, 3, 2, 2, 1, 1. So here's what I'm left with. That's my shortcut. I'm taking 10 times 9 times 8 times 7. Okay, so hopefully that makes sense when we think about the situation we were just talking about. So if I have 10 students, but there was only 4 spots for them to line up at the door, I've got 10 options because there's 10 kids. Someone lines up. Now there's 9 options because there's 9 kids remaining. And then there's 8 options because there's 8 kids remaining, and 7 options because there's 7 kids remaining. And we would stop because there were only 4 places we were going out to. There were only 4 spots to line up. Okay, so I multiply those together and I get 5,040. Okay, now if you're doing this by hand, I would suggest using that shortcut. You start with 10, you go out to 4 spots. Okay, that's what's going to happen every time because you're always going to be able to cross all these things out from that formula. Or you can memorize this formula and fill it out the long way to come up with that. Okay, or you can use your calculator, and I'm fine with that. Your work is to tell me 10p4, and that's what you put into your calculator. So if you have a graphing calculator, you're going to look for that math button. And then once you select math at the top, you need to arrow over a few times, and you should see PRB for probability. Okay, select probability, and then you will see some options below. The second option, the second button is an NPR. The third button is an NCR, which we'll look at that next. The fourth button is a exclamation point, so that's your factorial button. So you can calculate, like we did 8 factorial above, you would just type in 8, you go to math, arrow over to PRB, select 4 to calculate 8 factorial. So you can do that as well. If you are doing this problem that we just did, you would type 10 in first, that's our first number here. Then I would go to math, arrow over to PRB, select NPR. So some of you might see it show up as NPR if you have like a TI-83, and then you'd press 4 and equals to get your 5,040. Those of you with some newer, nicer calculators, it will fill in those little spots for you, so it'll look like how we write it. Okay. If you have questions on how to do it in your calculator, please let me know. Usually I kind of walk around the classroom and make sure everyone knows how to do that. But we'll just move on, I guess. All right, so that was permutation where the order matters. A combination is where the order does not matter, and we will look at examples of what that would mean shortly, and we'll look at both combinations and permutations. Okay, they each have a formula. It's very similar to the last formula. Here's the part that is different. You have r factorial. In the last formula, no r factorial. Okay, otherwise they are identical. Okay, so same thing, there's a button in your calculator, you find it in the same spot as you do the NPR, and you can do that, you can memorize this, and I'll also show you a shortcut as well if you don't have a calculator that performs either of those. Now, a combination, the order does not matter. A permutation, it does. So it will matter when we get to a situation whether you know which one to use, because we will get a different answer. Okay? So if we have 12C3, that means there are 12 items of a situation and we are choosing 3, okay, where they're not in a specific spot, so we're not lining them up. So if we're kind of talking about the same situation, if I had a class of 12 students and I just want to select 3 students, not really for any particular reason, I just want a group of 3 kids to, I don't know, work on a problem together, I would use a combination. If I wanted to rank those students in an order or line them up, I would use a permutation. Okay, so I'm going to do 12C3. We're going to use this formula up here so you can kind of see how it works. So I've got 12 factorial, r is my 3, so 3 factorial, and 12 minus 3 factorial. So that would be 3 factorial times 9 factorial. Okay, so the only part that makes it different than the permutation, I want a different color there, is that 3 factorial. So when I go to write this out, 11, 10, 9. So I hope you won't do this every time because it does take a while. The 3 factorial, 3 times 2 times 1, and then my 9 factorial. Okay, so the same thing happens as what happened with the permutation because it's really the same formula. So this happens every time, except we'll have this extra part. That's that 3 factorial or that r factorial. Okay, so my shortcut would be take 12 times 11 times 10, because I start with the number 12. I go out to 3 places, but then I must divide by a 3, 2, 1. And that's what makes it different than if it was a 12p3. Okay? You can go ahead and multiply out the top, then divide by 6 on the bottom. You can do some other little tricks like 3 times 2 is 6. 6 goes into 12 2 times. So then I'm taking 2 times 11, which is 22, times 10 is 220. So I don't always have a calculator in front of me, so that's how I do the problems a lot, especially when I'm teaching it in class, but you're welcome to just type that into your calculator. Okay, you can use the NCR button on the graphing calculator like I explained on the last problem. If you have a scientific calculator, I don't think I said this on the last example, you should have a PRB button where you can select NCR, NPR, and factorial. Okay. All right. So now we're going to get down to the last 6 examples here where it's not telling me which one to use. So now I got to figure out which one it would be. Okay. So a lot of times this is the most difficult part for students. Okay. Otherwise, it's knowing the formulas or how to do it in your calculator. All right. So I have 9 students who are entering a race. There is going to be first, second, and third places will win medals. In how many ways can 9 runners finish first, second, and third? So no ties are allowed. So I got to think about, does an order matter if I have first, second, and third place? Yes, it does, because they have a specific place, a position, an order. So this means I have 9 people. I'm using a permutation for the specific order of the 3 spots. So first, second, and third. If I'm doing this by hand, my shortcut would tell me start with 9, go out to the 3 places, 9 possibilities for someone to win. Only one person can win because there's no ties. Then there are 8 possible people remaining to get second place. No ties, so then 7 remaining after that. So 9 times 8 times 7 would give me 504 options. Okay, for my second example, it's very similar to the first example, but I want you to see the difference in how it's worded. So we still have 9 students in the race, but we are going to select 3 of those 9 students to form a team. Okay, so we are selecting a group at the same time. They are not individually going to a specific place, order, or position. So I created this example to now be a combination. Okay, you can use the C button for your calculator. This would be your work. If you were doing a test or a quiz, it would be 9C3, so I know what you're typing in. If you are doing this by hand, because you don't have a calculator that performs that, by hand, I would start with 9, 8, 7, but I must divide by this number's factorial for it to be a combination. Okay, the same exact numbers for when you're using a permutation or combination. Combination will always be smaller because you must divide by that r factorial. Okay, so I'm taking 504, dividing it then by 6 to get 84 options. Okay, so number 3, different examples. So our reading list for contemporary literature, there are 20 books. In how many ways can you choose 4 books to read? So we got to think about, is there a specific order, ranking, position, lining these books up? No, I am just selecting 4, a group of 4 to read. So that makes it a combination. Okay, you can use your calculator button. If you're going by hand, I'll start with 20, 19, 18, 17. I stop at 17 because that is the 4th number. For combination, I must divide by 4 factorial. You can multiply out the top, multiply out the bottom, divide it by 24. That'll work. And then we'll get 4,845. All right, 3 more examples to take a look at. So number 4, we have 10 candidates are running for 3 seats in the student government. You may vote for as many as 3 candidates. And how many ways could you vote for the 3 candidates? So I have 10 people. I need to think about, is there a specific order? Am I ranking these people? Am I putting them in a specific position, lining them up? No, I am selecting 3 from the 10. So that is going to be another combination. So if I'm doing this by hand, I go up to 3 spots starting with 10, and I must divide by that 3 factorial. So I'd have 720 divided by 6, so 120 options. Now I set up example 5 to be really similar to example 4. 10 candidates are running for 3 seats in the student government. We have a president, a vice president, and a treasurer. In how many ways could you vote for the president, vice president, and treasurer? So you have 10 candidates. You are still voting for 3 people, but now they have a specific position or place, right? Before we just voted in 3 people, those 3 people are going to serve on the student government. We are still going to have 3 people serve on the student government, but now 1 is a president, and only 1 can be the president. Only 1 can be the vice president, and 1 can be the treasurer. So now that makes this a permutation for those 3 people. So 10 options, 9 options, 8 options. I don't divide by a 3, 2, 1 because this is a permutation. So I have 720 options. Okay. Last problem number 6, you have 6 perfect attendance awards. Congratulations. And how many ways could you arrange the trophies on your shelf? Okay, so I am arranging all of them. A lot of students get confused because they typically look for 2 numbers. We got 10 and we got 3. Okay, and they see 6 and there's no other number. But we are arranging all of those trophies on our shelf. So we've got all 6, and we're going to arrange all 6. Okay, and so I need to think about, does this have an order? If I'm arranging it on my shelf, it's going to have a specific place. So this is going to be a permutation. This would be considered lining up. Okay, so I take 6, 5, 4, 3, 2, 1. Or this is just a 6 factorial problem as well if I'm taking everything, lining everything up. So this will end up being 720. Okay, there are quite a few problems in your homework, but it doesn't take a long time to do. And then make sure you understand the difference between the combinations and permutations. Obviously in Math Excel, if it tells you you're wrong, you can go back, try it as a permutation, see if it works, but you will not have that luxury for a test or quiz, so make sure that you are understanding the difference. All right, good luck on your homework.